I'm going to make a code in Grasshopper for exercise 13.1, that is the origami plated structure 1, and I'm going to do it by angle. So we will start with a rectangle. Okay, this rectangle I'm going to give letters A and B to the lower corners, and we are going to create a midpoint between A and B that we shall call it C. Now, C is going to be our axis, and we are going to rotate A and B in according to this vertical axis. So let me try to make here a real quick drawing so you can understand exactly what I intend. Okay, so this is the fold position. Now I'm going to draw the close one, or the not revolve. So we are going to have here an angle. Okay, this is C, we have point A, and here we have point B, and this can rotate also to the back and to the front. Okay, so this is the main idea. We have an axis. This axis is equidistant to A and to B, and according to our specific angle it is going to fold it. Okay, so now I'm going to put the variables. So I'm going to make this text slightly bigger so we can see them. Now, I know that I have an AB segment, and this segment is going to be equal to the length of my rectangle. I'm also going to have a height. Okay, so it will be this dimension. I'm going to have an angle. Now my angle is going to be mathematically between minus 90 till 90. Okay, so this transform into a Grasshopper code should be minus 89.99, smaller than 89.99. Okay, so like this, 90 angle are excluded. Another thing we need to do is, I think, okay, so length, height. For the moment, I think we have the three variables. If we add more, we shall apply it. Okay, so perfect. Now we can make this slightly smaller. 26. We can put it here. Now we can zoom this, and we can start code. So I'm going to double click, and I'm going to say, I remember. Now the height is going to be between 1 and 24 with 2 decimal places, and our length is going to be equal to that. So I will double click, 1 smaller than 24.00. Okay, this is going to be my length. Okay, and I'm going to double copy. I'm going to say height, the same value. So length I'm going to put like 24, and the height I'm going to put around 10. Now the angle minus 89.99, 89.99, enter. This is going to be angle, and as the angle is in degrees, I have to transform them into radians. I'm going to put rad here. Okay, so it's already transformed. So let us move length. Now, if I go to maths and divide this value by 2, I'm going to obtain my AC or my CB segment. And okay, so with this I have my, let us call it here, AC segment. AC equals to CB segment. Okay, so we have here the segment. Now I'm going to click point, and I'm going to click randomly here in Rhino. Then I'm going to get again in Grasshopper. I'm going to call point, so parameter point, right mouse click, set one point, and I'm going to apply that point. So this will be my origin point. Okay, so perfect. Now, in order not to have to open or to apply a point whenever I want to open this code, I'm going to internalize data. That is, I'm going to import this data. Now, the next thing I have to do is I have to obtain the coordinates in X, Y, and Z, and then obtain points A and B. So the first thing I have to do, vector, point, deconstruct point. So I'm deconstructing the point. And I want to construct two new points. I want to have point A and point B. Now, by default, this origin point is my C. So here, point A, here, point B. Now, I'm going to do it according this axis. So I'm going to say that Y and Z are going to be exactly the same. So I connect them. Now the X for point A is going to be a subtraction. Okay, so the original X minus this segment. Let me rearrange. Okay, is going to be that one. Okay, so CA, and for point B it's going to be an addition. So X plus this segment is going to be that one. So here we have. So if I change the length, they will get closer. If I move them, they will be bigger. Okay, I remember the fourth variable. That is the number of divisions. Okay, I'm going to say 1 smaller than 12. Okay, so we have this point. Now, if I'm going to do one thing here, I'm going to get here another point, and I'm going to call it point C. that in reality is this point. Okay, they are the same. And I'm going to right click over wire display hidden. So they are connected wireless. So I'm going to put here point C. And what I'm going to do now, let me see, like this we can see the code. I'm going to make two lines, LN, LN. So both lines will start in point C and they will end in point A and in point B. Okay, so here they are. Now I want to rotate. Okay, so I'm going to, let me better here, transform Euclidean normal rotate. Okay, I'm going to rotate this one and I'm going to rotate it. So I want to rotate this line and this other line. P is the center point of our rotation, so it will be C in both cases. And the angle, I'm going to move this down. I'm going to grab this. It's going to be positive for B, and it's going to be negative. So I double click on the canvas, I write negative here to A. Okay, now I have 90, so we are not able to see. So we can see them going from one side to another. So this means that these two lines can be hidden, and also this point B can be hidden, and this point A. Now, to call this menu, I'm clicking on the space bar on the keyboard, and I'm choosing disable preview. Okay, so now let me rotate. Okay, perfect. They rotate. Now, if as I have the lines, both lines start in point C. So these points are the starting points. So if I go to curve analysis endpoints, so let me see endpoints here, copy paste, I'm going to get the start point of both, that is C, and I'm going to get the endpoints. These endpoints in reality are rotated A point and rotated B point. This means that if I draw a line or a vector, in this case I'm going to draw a line here, endpoint, start endpoint, okay, like this line, in fact it will behave like a vector. Why? Because it has a start and the end point. This means they have a direction and an amplitude, and this creates a vector. If I wanted, I could go to vector, vectors, vector 2 points, and instead I should use A and B. Okay, these two in this case are exactly the same. The difference is that the vector is not shown, but it exists. Okay, the line, you can see the line, so you can confirm if the points are the correct order. Now I'm going to click here again and say 1 smaller than 12. So we will have here our end division. Okay, number of divisions. And I'm going to put like 4. Now what I'm going to do next is going to transform array, and I'm going to choose linear array. Okay, I'm going to make this smaller. Okay, I think you can see them. still. Now, what kind of geometry do I want to route? In this case, array. Well, I want to array this line and this. That is these two lines. So I can create here a merge. So this one and this are going to be array. D is going to be the direction. So we can use, in this case, the line, or if you prefer, you can use the vector. Okay, it's exactly the same. They will work the same. So you can see them here. N is the number of times. So I just click here, number of times. Let me zoom out so you can see 1, 2, 3, 4 pairs. Let us see them increasing, decreasing. Okay. Now let us see the angle, bigger, smaller, open, reverse to the other side. Okay, perfect. Okay, so this is our fixed point, the origin point that we decided to apply. And now what I have to do is I have to make an extrusion. The extrusion are under a surface, freeform, extrude. I want to extrude all this geometry according to a certain direction. That is, I'm going to double click and write Z. Okay, Z unit. Or if I went to vector, vectors Z unit, I will get the same. So I'm going to connect the height to this one and V there. So now I have all this. Now what I'm going to hide is I'm going to hide all my code. Well, parameters are not possible to be hidden. In this case, number sliders, space key, hide, and now I just leave the end part, so this one. So I can choose my angle, I can choose the number of divisions. Okay, now just to finish, I'm going to zoom in here, and we can go to display, preview, and there is one thing called custom preview. In reality, what I'm going to do is I'm going to apply a color. Okay, now I'm going to hide the extrusion, and by default I have this pink color. If I want to change, I have to go to parameters, input, color swatch. Now the default is white. If I connect, they will become white. In this case, a grayscale. I click here, and now I can move towards, and I can choose a blue one, a light one. Okay, so we can choose a different color around this. So, well, for the moment, I think this. If we want, we also can apply some alpha code or some alpha channel that is transparency. So totally opaque, totally transparent. We just see the lines, the edges, and here we can see the faces. So let us make like this, accept, and our code is done. Now, to save the code, I'm going to File, Save Document. Now I'm going to choose here my desktop, and you should save this as ex13.1 minus your student number minus your student student name. Okay, this is going to be saved in gh, that is grasshopper. So save, and then you have also to save the code image. So file, export high resolution image. Well, here you have to specify where you want to save it. So I'm going to choose desktop. I'm going to copy paste the name, and I'm going to click save. Now this is not going to save, but it's going to memorize the name that you want to save. Okay, so perfect. Now I'm going to put an alpha channel 255 that is totally white. You can see here, because I know if I use transparency I might get some errors. So I'm going to put opaque. Okay, white, opaque. So I'm going to click here. After I click, it's going to appear a black window with some numbers, and when this window disappears, it means that I've saved my code. Okay, so okay, the black window, then, and now we are done. So let me just